Scalable link interface is a brand name for a multi-GPU technology developed by NVIDIA for linking two or more video cards together to produce a single output. SLI is an algorithm of parallel processing for computer graphics, meant to increase the processing power available for graphics. The acronym SLI was first used by 3DFX for Scan-Line Interleave, which was introduced to the consumer markets in 1998 and used in the Voodoo 2 line of video cards. After buying out 3DFX, NVIDIA acquired the technology but did not use it. NVIDIA later reintroduced the SLI name in 2004 and intended for it to be used in modern computer systems based on the PCI Express bus. However, the technology behind the name SLI has changed dramatically. Implementation: SLI allows 2, 3, or 4 graphics processing units to share the workload when rendering real-time 3D computer graphics. Ideally, identical GPUs are installed on the motherboard that contains enough PCI Express slots, set up in a master-slave configuration. All graphics cards are given an equal workload to render, but the final output of each card is sent to the master card via a connector called the Sli Bridge. An example: in a 2 graphics card setup, the master works on the top half of the scene, the slave the bottom half. Once the slave is done, it sends its render to the master to combine into one image before sending it to the monitor. The Sli bridge is used to reduce bandwidth constraints and send data between both graphics cards directly. It is possible to run SLI without using the bridge connector on a pair of low-end to mid-range graphics cards with NVIDIA's Forsware drivers 8020 or later. Since these graphics cards do not use as much bandwidth, data can be relayed through just the chipsets on the motherboard. However, if no SLI bridge is used on 2 high-end graphics cards, the performance suffers severely as the chipset does not have enough bandwidth. Configurations currently include 2-way, 3-way, and 4-way SLI. Uses 2, 3, or 4 individual graphics cards respectively. 2 GPUs on 1 graphics card. Examples include the GeForce GTX 590, GeForce GTX 690 and the GeForce GTX Titan Z. This configuration has the advantage of implementing 2-way SLI, while only occupying 1 PCI Express slot and 2 expansion I/O slots. This also allows for 4-way SLI using only 2 cards. NVIDIA has created a set of custom video game profiles in cooperation with video game publishers that will automatically enable SLI in the mode that gives the largest performance boost. For more information on SLI-optimized games, visit NVIDIA's SLI Zone. SLI Modes. SLI allows for the following modes. Split frame rendering. This analyzes the rendered image in order to split the workload 50/50 between the 2 GPUs. To do this, the frame is split horizontally in varying ratios depending on geometry. For example, in a scene where the top half of the frame is mostly empty sky, the dividing line will lower, balancing geometry workload between the 2 GPUs. This method does not scale geometry or work as well as AFR, however. Alternate frame rendering. Each GPU renders entire frames in sequence. For example, in a 2-way setup, one GPU renders the odd frames, the other the even frames, one after the other. Finished outputs are sent to the master for display. Ideally, this would result in the rendering time being cut by the number of GPUs available. In their advertising, NVIDIA claims up to 1.9x the performance of one card with the 2-way setup. While AFR may produce higher overall frame rates than SFR, it also exhibits the temporal artifact known as micro-stuttering, which may affect frame rate perception and input response. Sli Anti-Aliasing. This is a standalone rendering mode that offers up to double the anti-aliasing performance by splitting the anti-aliasing workload between the 2 graphics cards, offering superior image quality. One GPU performs an anti-aliasing pattern which is slightly offset to the usual pattern, and the second GPU uses a pattern offset by an equal amount in the opposite direction. Compositing both the results gives higher image quality than is normally possible. This mode is not intended for higher frame rates, and can actually lower performance, but is instead intended for games which are not GPU-bound, offering a clearer image in place of better performance. When enabled, Sli Anti-Aliasing offers advanced anti-aliasing options, Sli 8X, Sli 16X, and Sli 32X. A quad Sli system is capable of up to Sli 64X anti-aliasing. Hybrid Sli, this is another mode that is not for performance enhancing. The setup consists of an IGP as well as a GPU on MXM module. The IGP would assist the GPU to boost performance when the laptop is plugged to a power socket, while the MXM module would be shut down when the laptop was unplugged from power socket to lower overall graphics power consumption. Hybrid Sli is also available on desktop motherboards and PCs with PCIe discrete video cards. NVIDIA claims that twice the performance can be achieved with a hybrid Sli-capable IGP motherboard and a GeForce 8400GS video card. NVIDIA has a similar technology called NVIDIA Optimus. Caveats: not all motherboards with multiple PCI Express X16 slots support Sli. Recent motherboards as of August 2014 that support it are Intel Z and X series chipsets and AMD's 990FX chipset. Aside from a few exceptions, older motherboards needed the N4 series of chipsets to allow for Sli. In an Sli configuration, cards can be of mixed manufacturers, card model names, BIOS revisions or clock speeds. However, they must be of the same GPU series and GPU model name. There are rare exceptions for mixed Sli configurations on some cards that only have a matching core code name, but this is otherwise not possible, and only happens when two matched cards differ only very slightly, an example being a differing amount of video memory, stream processors, or clock speed. In this case, the slower lesser card becomes dominant, and the other card matches. Another exception is the GTS 250, which can Sli with the 9800 GTX Plus, as the GTS 250 GPU is a rebadged 9800 GTX Plus GPU. In cases where two cards are not identical, the fastest card or the card with more memory, will run at the speed of the slower card or disable its additional memory. Sli doesn't always give a performance benefit in some extreme cases. It can lower the frame rate due to the particulars of an application's coding. This is also true for ATI's Crossfire, as the problem is inherent in multi-GPU systems. This is often witnessed when running an application at low resolutions. VSync plus triple buffering is not supported in some cases in Sli AFR mode. Users having a hybrid Sli setup must manually change modes between hybrid power and GeForce Boost, while automatically changing mode will not be available until future updates become available. Hybrid Sli currently supports only single-link DVI at 1920A, 1200 screen resolution. When using Sli with AFR, the subjective framerate can often be lower than the framerate reported by benchmarking applications, and may even be poorer than the framerate of his single GPU equivalent. This phenomenon is known as micro-stuttering and also applies to Crossfire since it's inherent to multi-GPU configurations. See also, Scan-Line Interleave by 3DFX, AMD Crossfire X AMD's competing solution, multi-chrome, micro-stuttering, conventional PCI, references. External links, official website, A.